2.2, solving linear systems by the Gauss-Jordan method. We're going to take a system of equations that looks like this and turn it into what's called an augmented matrix. Basically, what you're going to do is take out all the variables, okay? So look at the top row. The top row has a coefficient 2 for the x, 1 for the y, -1 for the z, and then skip a little bit of space, and the last number is 2, okay? Basically, what we're going to do is we're going to draw a vertical line here to kind of symbolize the equal sign. You may or may not need that, but we're going to draw it in there to symbolize the equal sign. Look at the second row. Coefficient 1 for the x, 3 for the y, 2 for the z, and your constant is 1. Bottom row, coefficients 1, 1, 1, and constant 2. So put your square brackets around that to make it a matrix, and that's the augmented matrix. We're going to do row operations, and that's the same thing as what we did in the last lesson, the Echelon Method. We can exchange rows, we can multiply an equation by a number, all right? Or you can think of division as multiplying by the reciprocal or vice versa. 3, replace an equation with a multiple of itself plus a multiple of another equation. That's the hard one, okay? But it's the same as what we were doing for Echelon Method. It's the same thing. We just don't have to worry about the variables. So I kind of like it better without the variables to confuse me. All we're looking at are the numbers. How to solve a system of equations by the Gauss-Jordan method. Step 1, write the augmented matrix. Step 2, use row operations to produce numbers along the main diagonal and zeros in the lower left and upper right triangles. Okay, so this is where it's different than Echelon Method. Echelon Method, we wanted a triangle, right? Okay, but in Gauss-Jordan, we're going to do something a little bit more. So instead of producing like a triangle, it's going to look something like this, okay? That's a 2 in the middle there, not a Z. Anyway, that's a 2. Okay, so notice it says we want numbers along the main diagonal. That's this. Oh, that's not a diagonal line, is it? Okay. Do I have a highlighter? I don't know how my highlighter works. Anyway, let's do this. Sorry. Right there. Numbers along that diagonal. Okay. Echelon Method, we had numbers in that triangle. Okay. But this is a little bit harder because we're going to have to produce more zeros. So look at all the zeros. See all those zeros? All those zeros mean we're going to have to do a rule to produce those zeros. So if you think about this specific matrix has 6 zeros, that's going to come from 6 of those row operation rules. Row 2 minus row 1, or 2 row 3 minus row 2, or something like that. All right? So everywhere you see a 0, we're going to have to use one of those rules. Once you get the hang of it, it's not that bad, and I'll show you how to use technology also. So here we go. Use the Gauss-Jordan method to solve each system. 2 equations is really not that bad. Step 1 is write the augmented matrix. So we take the variables out. We're going to have 4, 5, 10, 7, 8, 19. Augmented matrix. All right. Now, deep breath. Okay. Deep breath. Think about what we want. We want these numbers here. technically we want them to be ones, but we can always make them ones by dividing at some point or multiplying by the reciprocal. That'll be easy to get those to be ones, okay? But the 5 and the 7 we're going to have to make into zeros. So I pretty much will go from left to right. All right, I'm going to make the 7 a 0, and then I'm going to make the 5 a 0 later. All right. So what you have to do is you have to use this 4 to knock out this 7. All right, that's what we're going to do. We need a rule for that. It has to do with the LCM. So you're thinking about the least common multiple of 4 and 7. Anybody know the least common multiple of 4 and 7? 28, right? 28. So what you're going to have to think of is a way to make 28 minus 28 or negative 28 plus 28. You need something with 28 to make 0. Some kind of statement to make 0. So, all right, 28 minus 28. There's a couple of different ways to do that. All right. But one way is to take 4 of the 7s minus 7 of the 4s. That would make 28 minus 28. Remember, what I had to do was use this 4 to knock out this 7. So I've got to use a 4 and a 7. So all I have to do is multiply by the other. All right, that should work. Now, all of that I wrote down in blue, I'm doing that in my head. I'm not writing that down. I don't expect you to write that down. But I'm just trying to explain what we're trying to do. It has to do with the LCM. Once you get the LCM of 28, you need to make some kind of statement that says 28 minus 28. So you would take 4 of the row 2 numbers, which was your 7, and subtract 7 of your row 1 numbers, which was the 4. Very similar to what we're doing in Echelon Method, right? It's the same thing. It's the same exact thing. We just don't have to deal with the letters, the X's and the Y's and stuff. Okay, but otherwise it's the exact same process. So the top row doesn't need to do anything. Let's just leave it alone. 4, 5, and 10. But the bottom row I'm going to change. I'm going to modify according to that rule. So 4 row 2s, that's going to be 28. Okay. Minus 7 row 1s, that's going to be 28 minus 28, that's going to be 0. So with Echelon Method, we left it blank, but with Gauss-Jordan, we're going to need to write that 0 in there. Okay, we want the zeros, write the zeros. But now we need to continue and do more arithmetic, okay? So feel free to get out a calculator here. If you've got 4 of the 8s, somebody get out a calculator here, minus 7 of the 5s, that's 32 minus 35 is negative 3. Okay. I don't want to write all that down. That's why I'd say have a calculator out. Okay. Calculator, use your parentheses, type it all in. I'd type in 4 times 8 minus 7 times 5. I type the whole thing in. Okay. And you get negative 3. All right. So now we're also going to do 4 of the 19s. Minus 7 of the 10s. So 4 row 2s minus 7 row 1s. What's 4 times 19? 76. Minus 70 is 6. Okay. Now, if you think about it, the first column, don't write this down, was representing the X, and the second column was representing the Y variable. Right? So if you look at this bottom row right here, basically what that says is negative 3y equals 6. All right? We don't need the variables in there to know that that means negative 3y equals 6. And so really all we'd have to do is divide by negative 3 and we would find that y is going to equal what? Negative 2. Y is going to equal negative 2. Okay? So understand that these numbers are representing the coefficients of an equation. All right. So one of the operations that I'm allowed to do, remember, is to multiply a row by a number. We're going to call it division here, but we're multiplying by negative 1/3. But let's think of it as divide by negative 3. Take that second row and divide by negative 3. You would get 0, and 1 and negative 2. Think about what that row means as an equation. What does 0, 1, negative 2 mean as an equation? Well, that just means y equals negative 2, right? That shows you your solution. That shows you that part of the solution. Okay? Now, here's where it's going to be different than Echelon Method. Echelon Method, you took that y equals negative 2 and you plugged it in above. Okay? And I know you could do that right now, but that's not Gauss-Jordan. Gauss-Jordan wants another 0. Okay? Gauss-Jordan wants a 0. So what we're going to do is we're going to take this number right here and use it to knock out that 5. Okay? We're going to use another rule to knock out the 5 with the 1. So we need 5 minus 5. We need a rule that says 5 minus 5. So what if we said row 1 minus 5 row 2s? I'm taking my 5 in my row 1, and I'm subtracting 5 of those 1s in row 2. That should make 0. Okay? So let's apply that rule. Row 1 is 4 minus 5 of these zeros. You should be able to do that in your head. It's going to be 4. Okay? Because we took 4 minus 5 of the zeros is going to equal 4. And then we're going to take this 5. Row 1 is 5 minus this row 2, or 5 of those row 2s. That's going to be 5 minus 5 is 0. So that's 0. Now move over to the 10. Row 1 says 10 minus 5 of the row 2 numbers. That's going to be 10 plus 10 is 20. Okay? So we didn't need to do anything to the bottom row, 0, 1, negative 2. At this point, I can see the answer. Okay? Because what does that top row represent? What equation? Well, it has an x in it. Yes, that's right. But it's 4x equals 20. That top row says 4x equals 20. So you should be able to see that x is going to equal what? 5. Okay? But with Gauss-Jordan, we want 1s and 0s at the end of the story, basically. So I can just divide that top row by 4. Okay? Divide that top row by 4, and you would get 1, 0, 5. I forgot my vertical bar. And you'd have 0, 1, negative 2 on the bottom there. Which tells me that my final answer, you can see the top row says x equals 5, and the bottom row says y equals negative 2. Now, I know that's a lot to process for the first one. Okay, seems like an awful lot of work, but once you get going, it goes a lot faster. It always takes me a lot longer to explain it. So let's look at example 2. Okay, example 2. Same thing. We start with an augmented matrix. 1, negative 2, bar 2, 3, negative 6, bar 5. That's my augmented. Okay. Gauss-Jordan wants numbers along the main diagonal and zeros everywhere else on the left. Okay. So we're going to use this 1 to knock out this 3. That's what we have to do. So your job is to find a rule that's going to use the 1 to knock out the 3. LCM of 1 and 3 would be 3, right? So we want a statement that's going to say 3 minus 3. There are several ways of doing it, but what I might do is row 2 minus 3 row 1s, because that's going to be 3 minus 3 times 1. That's going to make 0, right? So leave the top row alone. We're not changing the top row yet. We're changing the bottom row because I want to change that 3 into a 0. So if I do row 2 minus 3 row 1s, I'd have 3 minus 3 times 1. I'd have 0 there. Okay, good. That's what I wanted. So apply that same rule. Okay, row 2 minus 3 row 1. Row 2 is negative 6. minus 3 times row 1 is negative 2. Now that's going to be negative 6 plus 6 is 0. So there's going to be a 0 there as well. Something weird's going to happen. Because remember what I want. I want numbers along that main diagonal and zeros everywhere else. So this is something weird's going to happen. Something different. Let's continue and let's do row 2 is a 5 minus 3 times row 1 is a 2. That says 5 minus 6 is negative 1. Okay, negative 1. Think about what that bottom row says as an equation. Can anybody tell me what that bottom row says as an equation? It says 0x plus 0y equals negative 1. Or if you clean that up, it would say 0 equals negative 1. Okay? That's supposed to tell you something. That's mathematical nonsense, right? What does mathematical nonsense tell you? This one will have no solution. If I graphed the two lines, what would I see? The two lines would be parallel, right? No solution. They wouldn't cross. They wouldn't have any intersection. Okay, so this one is no solution.